Good morning. Welcome to RAAONLINE. In today's session, we are going to cover the blood supply of the brain. Under the competency-based CBME curriculum, it is covered under AN 62.6, where apart from the blood supply, in which the circle of Willis is very important part, has been described, and to identify the formation, branches and its major areas of distribution. Why is it very important for the brain's vascular supply? Yes, blood supply is important for all the organs of the body, no doubt about it. But if you see the cardiac output, the percentage of cardiac output that flows into the brain, it's 15%, a lion's share. And the amount of oxygen that is consumed by the body, again a lion's share of 25% is consumed by the brain. Why is it so? Brain is constantly under activity. The neuronal activity is so very constant that it drains, or it rather draws a lot of metabolic activities and metabolic output. So it has to be the constant metabolism involved in the brain for the neuronal circuitry consumes that much amount of oxygen. So for that there has to be an uninterrupted supply of blood. This is maintained by having a capillary blood pressure in the brain is maintained around 50 millimeters of mercury, so that whatever be the changes in the systemic pressure, say from 65 millimeters of mercury to 140 millimeters of mercury, this capillary pressure is maintained, so that the blood flow to the brain is not compromised unless there is a drastic change in the systemic blood pressure. So this much is important for the brain to have the blood supply. Loss of consciousness, that LOC that is written is loss of consciousness. So loss of consciousness of a human happens with less than 15 seconds of interruption of the brain's blood supply. So this will tell you the importance of continuous blood supply of the brain. Why is it so? Because there are very little reserves of glucose for metabolism in brain. So it has to be constantly circulation of the blood, constant supply of the metabolites only will help in the metabolism and thereby maintaining the brain's activity. So with less than 15 seconds of interruption of the blood supply, the person goes in for loss of consciousness, and if there is more than 15 minutes of interruption, then irreparable brain damage. The neurons die and it will be very difficult to regenerate them back. So the vascular supply to the brain is a very important component which is necessary for the proper life of an individual. And what is more important is they cannot survive for longer duration. A very short duration of interruption will lead to irreparable damage. So coming to what are the major vessels that supply the brain. So you can see the aorta here. From the aorta, you see the subclavian artery is what is shown here, and then part of common carotid is shown. Okay. So from the common carotid, it bifurcates into external carotid, internal carotid, and this internal carotid continues in the neck to supply the brain. So one system is the internal carotid vessels. The other pair of vessels that are responsible for the vascular supply is the vertebrobasilar system. The vertebral artery is a branch of the first part of the subclavian artery. So this vertebral artery, which is the branch of the first part, will then ascend in the neck, enters the brain, joins with the opposite vertebral artery to form the basilar artery. So this vertebrobasilar system is responsible for the vascular supply of the brain in association with the internal carotid arteries. So apart from these two pairs of major blood vessels, there is one circulus arteriosus. that is an arterial circle formed by the anastomosis of the two large vessels or its branches. So that is called a circle of Willis, and that is formed by anastomosis between the basilar artery branches and the internal carotid artery branches. You can see the internal carotid artery going like this. So that is giving a few branches which is connecting with the branches of the basilar artery to form the circulus arteriosus. So we will see about all these things in detail in the subsequent slides. Internal carotid artery. It is a branch of common carotid artery which I just told you in the previous slide. The external carotid artery continues to supply the face, neck and other structures. The internal carotid artery continues over the neck, enters the cranial fossa through the carotid canal. The lower carotid canal, by name itself you see canal, so it will have two openings. There is a lower opening and there is a upper opening. Both the openings are present in the petrous temporal bone. So petrous temporal bone, which is present in the middle cranial fossa. From the base of the petrous temporal, the lower opening is present, through which, this is what is depicted here. So through the lower opening, the internal carotid artery enters the cranial fossa. It traverses the petrous temporal bone. So this portion is the petrous temporal bone portion. So it traverses within the petrous temporal bone and then exits the petrous temporal bone through the upper opening of the canal, which is very much close to the foramen lacerum. So through the foramen lacerum in its upper part, the lower part of foramen lacerum is closed by a cartilage in the living persons. It then enters the cavernous sinus, and that after it traverses the cavernous sinus, it exits through the roof of the cavernous sinus to enter the brain next to the medial to the anterior clinoid process, just lateral to the optic chiasma. So this is where the internal carotid artery exits, and then it gives, that part is called as the cerebral part. Throughout this course of the internal carotid artery, which can be divided into cervical part, the part which is in the neck, the petrous part, the part which has entered the lower carotid canal, lower opening of carotid canal, traversing the petrous temporal bone and then coming out through the upper opening of the carotid canal and adjacent foramen lacerum. That is the petrous part, and then where it traverses the cavernous sinus is the cavernous part, and finally when it exits the roof of the dural venous sinus.